I want to talk a little bit about the relationship between critical points and inflection points and asymptotes and domains. Technically, a critical point and an inflection point, to be considered those things, they need to be within the domain of a function. But when we go to consider, for instance, in the first derivative level of doing things, when we go to consider where the function changes from increasing to decreasing, we need to consider the critical points that are in the domain as well as the asymptotes that are not in the domain. Let's look just at what happens with this function that I've drawn out here with increasing and decreasing. It looks like it's decreasing on negative infinity to negative 4, and then it continues to be decreasing until we hit 0, and then it's increasing, so we'd have a critical point here at x equals 0. But then note it goes from increasing to decreasing again once we go across x equals 3. And technically 3 would not be a critical point because it's not in the domain of the function. But we would definitely want to check the regions defined by x equals 3 for increasing and decreasing because it did switch from increasing to decreasing. So even though the asymptotes aren't technically critical points because they're not in the domain, when we go to check our regions and do all the procedures for the first derivative step of graphing a function, you essentially treat the asymptotes as if they were critical points. Some people even go so far as to call them critical points, even though that's not technically correct because they're not in the domain. Treat them as if they were critical points. The same goes for inflection points, or I guess what we'd call possible inflection points. Let's look at what happens here. We're now studying the second derivative level of things. It's concave down from negative infinity to negative 4. Now, negative 4 would not technically be even a possible inflection point because it's not in the domain of the function. However, we would certainly want to test that as one of our regions because look what happens on the other side of x equals negative 4. We're suddenly concave up, and then it looks like on the other side of negative 3 we remain, or sorry, on the other side of 3 we remain concave up. So again, with the second derivative level of analysis, you want to check the regions defined by the asymptotes, or the points not in the domain, to see if it switches from concave up to concave down. So essentially we treat those as if they were possible inflection points, even though because they're not in the domain, they can't actually be possible inflection points. It's just a small yet very annoying point about our definitions of critical points and possible inflection points.